Welcome back to our automotive testing series. Today we are looking at how professional engineers build the massive testing systems used in automotive industry. We are going to break down the concept Automotive Test Automation Framework. The secret to making sure modern vehicles are safe and reliable are here. Here is our journey for today. We'll start with the problem we are trying to solve, dive into the actual architecture of these systems, look at how they run in the real world, and finish with the professional standards that keep everything organized. Modern vehicles are incredibly complex with millions of lines of code trying to test every single feature manually or with simple uh, disconnected tests is impossible. As vehicles get smarter, the older way of testing just can't keep up. The solution is to move away from simple one-off scripts and toward professional frameworks. A framework is like a well-organized toolbox. It provides a structure that allows us to run thousands of tests automatically and efficiently. Think of a professional framework, test automation framework as a series of layers. By keeping different tasks in different layers, the system becomes tool agnostic. This means we can change our testing software or hardware without having to rewrite all our tests from the scratch. In the first layer, we separate the what from the how. The core logic layer handles the intent of the test, like turn on the headlights, without needing to know the technical details of how the car actually does it. Black box. Vehicles have thousands of settings and parameters. This layer handles all that information. Instead of we burying data inside the code, we manage it separately so we can easily test different car models or regions just by changing the data. This is the hardware abstraction layer. This is the translator of our system. The HAL allows our software to talk to the car's hardware. It's critical because it lets us run the same test on a virtual car or a real physical vehicle without changing the test itself. 1,000 tests are useless if you can't understand the results, right? This layer gathers all the data from our runs and turns it into a clear report or reports. It helps engineers quickly see what passed, what failed, where we need to focus our attention and analysis. Now let's look at the big picture of how this actually runs. This is an end-to-end pipeline where a test is triggered automatically, prepared, executed, and analyzed in one smooth continuous flow used by top automotive teams. The next slide says it. To move faster, we use continuous integration. This means the moment a developer changes the vehicle software, the testing framework automatically triggers the necessary tests to make sure nothing was broken. Sometimes simulation isn't enough. In this stage, we connect our framework to real automotive hardware. This hardware in the loop testing ensures the software works perfectly when it's actually installed in the vehicle. One of the most important rules is modularity. We build our tests like Lego bricks. Instead of one gain script, we create small reusable pieces that can be combined to build any test we need. To keep the system clean, we practice separation of concerns. Each part of the framework has one job, a dedicated job, and one job only. This makes it much easier to find bugs and update the system as the vehicle is going to evolve in the later stages. To wrap up, a professional automotive framework isn't just about writing code. It's about a solid layered architecture, a clear industrial workflow, and following high engineering standards to ensure safety and quality. So understanding the framework is just the beginning. Okay, in our next video we will dive even deeper into the automotive test execution life cycle to see the full journey of a test from start to the end. I'll see you there. Thank you.